learning blood pattern analysis. This is one of the most sought after labs in my class. Students watch this year to year. They want to know what's going on. They have a lot of fun in this. They learn a lot, and quite frankly, it's really messy. Now, we're going to show you a couple of different techniques and ideas. The ones we're going to do for you are going to be a tabletop version. I tend to go a little bit more overboard, and with that, we create a 6x8 room out of PVC pipe, draped in plastic, ceiling, floor, walls, for two reasons. One, it's a lot easier to clean up when you're done. And two, it allows us to see cast-off patterns and a lot further in-depth study of blood pattern analysis. Now, when you're doing this, it can get messy. This is a lab where I recommend that you and any students you have wear additional clothes and protective. I want goggles, I want aprons, I want clothes they don't mind getting dirty, because even with the synthetic blood we have, when you strike an object and there's a pool of blood, you're going to get a pattern that's going to go three-dimensionally. And that's a great aspect of this lab, is students tend to look at labs two-dimensionally, but we need to begin to get them to think as three-dimensionally: ceiling, floors, walls, themselves, their back on cast-off. So what we're going to do is we're going to walk you through various aspects ranging from creating your own blood. It is a good replica. Bit of a warning here, I did have a student that was vasovagal. You need to ask in advance. There are students that have a great difficulty working with any type of blood. In that case, instead of making it red, on theirs I made it blue, substituted the dye, and for whatever reason, they were more than comfortable working with it, because all fluids have the same flight dynamics, and that's what we're going to be working with. We'll teach you different cast-off patterns, high, low, medium velocity, and we'll go into in-depth on a few various aspects that may modify these labs to make them a little more applicable. But regardless, this is a lab that most students have a great time with. Let's go ahead and prepare our synthetic blood. Now, there are a lot of different recipes out there. This is one that I found when I was attending the AAFS conference. It's very simple. I started off with about 10 milliliters of water, and all I'm going to do is I'm going to go ahead, and I always buy things in bulk because it's cheaper that way. I'm going to go ahead and add about 5 to 10 mils of red food coloring. Okay. Now, what that's going to do is that's going to give us our red consistency, but it doesn't quite give us our viscosity that we're going to need. For that, there's a couple things you can do. I was informed by a gentleman who does this at an academy that he likes to put Jergens hand lotion in there. Another person instructed me to put in some Nestle's Quick, and that's what I prefer to do, because not only does it give us a little bit of the viscosity, but also it gives us a little bit of that browning that you're going to get with blood. So I put in approximately a teaspoon, maybe a little less. I check it along the way. There's no hard and fast rule. And what we're going to do is we're going to take our pipette and we're going to go ahead and stir this up. Now, you can heat this up partially in the microwave, but if you test this and it's warm like that, it has a little bit different effect. So if you're going to test it while it's warm, I want you to go ahead and use it while it's warm. And then what we're going to do is we're going to go ahead and get our note card, and we're just going to drop one drop from a defined height. Probably need a little more Nestle's Quick from this case. It actually doesn't look too bad. So what we get in this case is our synthetic blood. Let's talk about cast-off patterns. Now, when dealing with this, if you need any help, there's a wonderful resource. There's an internet site called bloodspatter.com. It goes through wonderful tutorials that will really help your students out. And this desktop version will give us similar results, but when we do this on the floor with a longer sheet of paper and a student moving at a much faster rate, it's going to be a lot easier to determine the angle of direction, or what we refer to as the cast-off. What we find is if we drop it 90 degrees, we're going to have spines that are nearly circular on the paper. And that's something that looks like this. If we were to look at this, what we'll see is the spines are nearly the same in all directions. When we're moving at a fast pace across a room, what's going to happen is the spines on the side that denote the direction are going to be longer. So if we're moving at a much faster rate, and it's hard to do on a desktop version, but if we're moving at a fast rate, what we'll see is like what we get right here. If we take a look at this, we'll see the spines on this side, the direction of movement, are larger than the spines on the opposite side. So this denotes direction. From this particular cast-off, we can tell that the movement, although 90 degrees, roughly 90 degrees, was moving from this first pattern all the way to this pattern. This is another really fun lab that I've had a great experience with my students with. This is determining impact angles. And what we're going to do is we need to lay a ground rule that this takes more than one person to do this. So we're going to have to modify a little bit for our display. But in essence, what we've done is we've taken a protractor and we've taped the protractor to the bottom of our ruler. That way we can hold this up so you get an idea. Now this note card is placed 90 degrees with the normal. So I typically break my students out to groups and I define the height. So let's just say hypothetically this one's dropping from 20 centimeters. So if they take this pattern and they drop this drop of blood, it's going to fall and hit at 90 degrees. And that's what we see right there. What we're going to do then is place this note card off so that it can dry, and we're going to take a new note card, and with that new note card we would increase our angle. This is where a lot of students have difficulty. We want to use this point of our fulcrum. If this is 90 degrees, 10 degrees further would actually be 80 to the normal. Once again 70 and then 60 and so on, all the way up to where we're going to have the students drop at 10 degrees because we're measuring not to the protractor but the normal. Now in this case, just from doing this a long time, this is about 45 degrees, okay, right about here. And what we're going to do is they drop from the same height on this note card, and when they drop at this angle, what you're going to see is it's a distinctively different shape. In this particular case, we will place these off to dry. We have our 90 degrees and roughly our 45. And in looking at that, it looks more like about 30 to be honest with you. And then eventually you'll do 90, 80, 70, all the way up into about 10 degrees. 10 degrees is going to be very elongated. It's one of the hardest ones to do. We're going to go ahead and drop, and you're going to get a nice pattern. What you would then do is you're creating a student standard. So they would allow this work to dry. They would begin to do measurements on 90, 80, 70, 60, and they'd also calculate a percent error. Once this dries, you have them measure the width and the length of each card and record it in millimeters. You need to be careful not to include the spines and or satellites. So on this pattern in particular, it's where this drop would naturally end if it wasn't for this one long giant spine, this satellite located here. What you can then do is take the width divided by the length. If you take the inverse sign of that value, it will give you your degrees of impact. And what this allows us to do is to give us an area of convergence. If we have a pattern, we can do what's referred to as a backtrack string. That's also available on this website, bloodspatter.com. A backtrack string into what we would call an area of convergence. So when you're done, every student should have a 90, 80, 70, 60, all the way to 10, because what you're doing is creating a standard that they can then use when they go out and analyze a perpetrator's hit or an arterial or some type of cast-off pattern. I would really like to ask you how your experience went on that. I know it can get kind of messy and a lot of fun at the same time. If you have resources, they do have these wonderful things called Spatter heads. I know that they're available through Len Peavy. Wonderful product to use. Some of you probably got real creative and tried some new things. And I really hope the experience was as wonderful for you in your classroom. One thing that I tend to see on my students is they get more involved in the activity and less with understanding it and getting some good results. It's okay to have fun in lab as long as you follow all safety guidelines. We know people do get hurt, and unfortunately some people actually die in laboratory difficulties. We want to avoid all that. But even with this lab, it could be a lot of hands-on fun time. Make sure though when you're done that you get back to calculating your angle of impact. You want to make sure to be able to determine the cast-off pattern type, potential weapon, tie this up into a really solid unit. And I know from my lab, this is a lab that I can let stretch out for as long as I want. I really have to set firm guidelines and get students into this hitting area inside these different protocol areas, whether it's desktop or whether it's inside the hitting area. I got to keep a pretty firm timeline. I encourage you to do that. And once again, hope you had a wonderful experience with this.